Lesson 7.3 Legal Document Analyzer Learning Objectives Violin Objectives. In this lesson, you're building a production-ready legal document analyzer, one that extracts key information from contracts, identifies obligations and risks, and generates structured summaries. This is a genuine domain adaptation challenge, and it demonstrates one of the most powerful things you can do with fine-tuning. Take a general purpose model and make it genuinely expert in a specialized field. Budget about 90 minutes for this one. It's advanced, and it assumes you've worked through modules 1 through 6, especially module 6.4 on continued pre-training, because that technique is central to what we're building here. Project overview. Here's the real-world problem we're solving. A law firm processes over 200 contracts every month. Right now, a human reviewer spends 2 to 4 hours on each one, manually reading, extracting key clauses, flagging risks. That's inconsistent, expensive, and error-prone. At roughly $150 to $300 per contract review, the costs add up fast. The target state we're building toward: automated extraction in under 5 minutes, 95% accuracy or better, consistent quality across every document, and a cost of $2 to $5 per contract. For a 50-lawyer firm, that's a potential $100,000 to $500,000 in annual savings. This isn't a toy project. Here are the concrete performance targets we're engineering toward. Extraction accuracy needs to exceed 93%, that's critical. Processing speed must stay under 30 seconds for a 100-page contract. Key entity detection needs greater than 95% recall, meaning we can't afford to miss parties, dates, or obligations. Risk flag accuracy must clear 90%, and false positives need to stay below 5% because false alarms erode trust fast. Every output must be valid JSON 100% of the time. These aren't aspirational numbers, they are the bar the model has to clear before it touches a real contract. Architecture overview. The pipeline has 3 distinct stages, and understanding why they're separate matters as much as understanding what each one does. Input documents arrive as PDFs or docx files and get converted to plain text first. That's just pre-processing, nothing exotic. Stage 1 is continued pre-training on a legal corpus. Before the model learns to extract anything, it needs to understand legal language at a deep level. The terminology, the sentence structures, the way obligations are nested inside conditionals. You can't skip this step and expect good results. Stage 2 is task-specific fine-tuning, teaching the model to identify parties, dates, and obligations in a structured way. Stage 3 is risk classification, detecting non-standard clauses and potential liabilities. The final output is structured JSON with confidence scores attached, so downstream systems know exactly how much to trust each extracted field. 5 technical challenges make legal documents genuinely hard for language models. First, legal language is its own dialect, specialized terminology, sentences that run for 200 words, clauses nested inside. Second, contracts are long, often 50 to 200 pages, which translates to 250,000 tokens or more. Third, understanding any single clause often requires context from the entire document. Fourth, extraction precision has to be exact. You need the actual clause text with its location, not a paraphrase. Fifth, risk assessment is inherently subjective. It requires domain expertise that has to be encoded into training data carefully. Each of these challenges shapes a decision we make in the architecture. Phase 1, Data Collection. The data collection script handles 3 distinct jobs. First, it creates a clean project directory structure, a small thing that pays off enormously when you're juggling multiple training stages. Stage 1 loads 2 legal datasets, the pile of law and quad, the contract understanding Atticus dataset. The pile of low gives us broad legal language coverage for pre-training. Quad gives us annotated contract clauses for extraction training. When this runs, watch the output for document counts and average document lengths. Those numbers tell you whether you've loaded the full dataset or just a sample. Stage 2 generates question-answer pairs from CUAD, teaching the model to answer specific extraction queries against contract text. Stage 3 prepares risk assessment examples, pairing contract clauses with expert risk judgments. The summary printed at the end is your checklist. Verify the document counts match expectations before moving to training. Phase 2. Multi-stage training. Stage 1 is continued pre-training, and the model choice here is deliberate. We're loading llama-3.2-3b-instruct with a maximum sequence length tuned for long documents. Legal contracts routinely exceed what smaller context windows can handle. LoRa is configured with a higher rank than you'd use for a typical fine-tuning job because we're trying to shift the model's general knowledge base, not just adapt its output style. Gradient checkpointing is enabled to keep memory usage manageable across those long sequences. When training starts, the output will show you how many documents are being processed and an estimated completion time. That estimate is worth checking against your available GPU hours before you walk away. After training completes, the adapted model and tokenizer are saved to disk. At this point, the model understands legal language. It doesn't yet know how to extract structured information. That's stage 2's job. Stage 2 loads the domain adapted model from stage 1. That's the foundation we just built. The load underscore and underscore 4-bit flag is on, which halves the memory footprint and makes training on 24 GB GPUs tractable for this task. LoRa is applied again, but with different parameters, rank 16 and a dropout of 0.1. The lower rank compared to stage 1 reflects the narrower goal here. We're not reshaping general knowledge, we're teaching a specific skill. The format underscore chat function is doing important work. It applies the model's chat template to every training example, ensuring the extraction queries and responses are formatted exactly the way the model expects to see them during inference. If this formatting is wrong, the model learns to extract information in a format it can't reproduce reliably. The training output will confirm how many examples were processed. Once complete, the extraction model is saved, ready for stage 3. Stage 3 introduces DPO, direct preference optimization, and this is where the model learns to make judgment calls about risk. The core idea behind DPO is elegant. Instead of showing the model correct answers, you show it pairs of responses, one that an expert preferred, one that an expert rejected, and train the model to prefer what the expert prefers. For risk assessment, this is exactly the right approach because risk is inherently comparative. The maximum sequence length drops to 2048 tokens here, appropriate for closed-level analysis rather than full document processing. The learning rate is set lower than in previous stages. DPO is sensitive to overshooting, and stability matters more than speed. The training data includes prompts with both chosen and rejected responses drawn from expert annotations. When training completes, the saved model represents all 3 stages of adaptation: legal language understanding, structured extraction, and expert-aligned risk judgment. That's your production. Phase 3, Valuation. Once CSN fired, the evaluation script runs 2 types of tests against a sample employment agreement. The first is functional. The test underscore extraction function sends specific queries to the model, parties, dates, obligations, risks, and prints the responses. Read these outputs carefully. You're not just checking whether the model returns something. You're checking whether the extracted values are correct, complete, and properly formatted as JSON. The second test is automated accuracy scoring. comparing model outputs against predefined ground truth. The output will show per category accuracy, parties, dates, obligations, risks, and an overall percentage. If overall accuracy clears 93%, you're within the target. If a specific category is underperforming, that's your signal to revisit the training data for that extraction type, not to retrain everything from scratch. Phase 4. Production deployment. The production API is built on Fast API, and the design reflects real deployment requirements. The model loads once at startup. You'll see a confirmation message in the terminal when it's ready, and then stays resident in memory to serve requests without reloading. The extraction request class defines what the API accepts, contract text, and a list of fields to extract. The extraction result class defines what it returns, structured results with confidence scores attached. There are two analysis endpoints. One accepts raw text directly, the other accepts PDF uploads. The health check endpoint at /health is not optional decoration. Monitoring systems and load balancers depend on it to know whether the services are live and the model is loaded. This is the difference between a demo and a system you can actually deploy. Two commands to verify the deployment is working. The first starts the server by running write legal_analyzer_API.py, write directly, once the model confirmation message appears in the terminal. The second command is a curl post to the /analyze/text endpoint. The DH flag sets the content type header to application/JSON. Without this, the server won't parse the body correctly. The byte flag carries the payload contract_text with the text you want analyzed and a fields array specifying what to extract. The response you get back is your ground truth check. Verify that the JSON is valid, that the requested fields are present, and that the confidence scores look reasonable. If the response is malformed or missing fields, that's a signal to check the model's output formatting, not the API layer. Results and KPIs, vanillas and KPIs. Here's how the system actually performed against the targets we set at the start. Extraction accuracy came in at 93.2% against a target of 93%, right at the threshold. Processing speed hit 18 seconds average against a 30-second target. That's 40% faster than required. Key entity recall reached 96.1%, clearing the 95% target. Risk flag accuracy. False positive rate came in at 3.8%, well under the 5% ceiling. The one metric that didn't fully hit target is JSON output validity at 98.7% versus 100%. That 1.3% failure rate means roughly 1 in 77 contracts produces malformed output, which is why the fallback handling in the API matters. Monitor that number in production and prioritize fixing it if it trends upward. The business impact numbers are stark. Processing time drops from 2 to 4 hours per contract down to 18 seconds, a 99.8% reduction. Cost per contract drops from $200 to $3. For a firm processing 200 contracts a month, that's over $400,000 in annual savings, but the number that often gets overlooked is throughput. The same infrastructure that handles 200 contracts a month can handle 1,000 or more without adding headcount. That's not just cost savings, that's a fundamentally different business model for legal services. Next steps, 5 directions worth pursuing from here. Expand the training data to cover SaaS agreements, real estate contracts, and M&A documents. Each has its own vocabulary and risk profile. Add multi-language support for firms operating across jurisdictions. Build a clause library that flags deviations from standard language, so reviewers know immediately when something is non-standard. Add a contract comparison feature for tracking changes across versions of the same agreement, and integrate with document management systems like NetDocuments or iManage so the analyzer fits into existing legal workflows rather than requiring a separate tool. Key takeaways: 4 technical lessons from this project. Multi-stage training, continued pre-training, then fine-tuning, then DPO delivers 15 to 20% better accuracy than jumping straight to fine-tuning. That gap is large enough to matter in production. Domain adaptation is not optional for specialized fields. Legal language has vocabulary and structure that a general-purpose model simply hasn't seen enough of. Structured JSON output requires extensive, consistent training examples. The model needs to see the output format hundreds of times before it reproduces it reliably. And context window sizing is a real engineering decision. 4096 tokens handles most standard contracts, but complex multi-party agreements may need 8004 deployment lessons that are easy to skip and painful to learn the hard way. Confidence scores are not a nice to have. Users need to know when the model is uncertain so they can decide whether to review manually. Every extraction must be logged with a full audit trail. In legal contexts, compliance requires it. The system must handle failed extractions gracefully with clear fallback behavior rather than silent failures. And for high-risk clauses, indemnification, liability caps, non-competes, keep a human in the loop. The model catches things humans miss, but humans catch things the model misses. The combination is what makes this production ready. The ROI case for this system is unusually strong. A 3 to 6 month payback period, the ability to handle 10 times the volume without adding headcount, and a meaningful reduction in the risk of missing a dangerous clause. Firms that deploy AI-assisted contract analysis have a real competitive edge, faster turnaround, lower costs, and a more consistent work product. This project is production ready as built. In lesson 7.4, we move to the next real-world application. This diagram shows the full document processing pipeline, and it's worth understanding each stage before writing a single line of code. Raw legal documents, PDFs or docx files, enter the pipeline and immediately go through OCR or text extraction. That step converts scanned or formatted documents into plain text the model can actually process. From there, section chunking breaks the document into semantically coherent pieces, preambles, recitals, operative clauses. So downstream components aren't trying to process an entire 200-page contract as one undifferentiated block. The clause classifier and entity extractor then run in parallel. One categorizing what type of clause each section is, the other pulling out named entities like parties, dates, and monetary values. Both feed into the risk scorer, which combines clause type and entity context to assign risk levels. Everything flows into the final analysis report. This pipeline is the skeleton of everything we build in this lesson. Named entity recognition is doing a lot of the heavy lifting in this pipeline, and this example makes the output concrete. From a single contract sentence, the model extracts 5 distinct entity types: ACME Corp as an organization, John Smith as a person, January 1st, 2025 as a date, 12 months as a duration, and $150,000 USD as a monetary value. Each of these maps to a structured field in the output JSON. The reason this matters beyond just labeling, downstream logic depends on these entities being correctly typed. A date misclassified as plain text won't trigger deadline alerts. A monetary value missed entirely won't appear in the financial summary. Precision here is what makes the difference between a system that surfaces useful information and one that requires a human to double check everything anyway. This precision and recall chart is your diagnostic tool for understanding where the model is strong and where it needs work. Precision measures how often the model's identifications are correct. When it says, "This is an indemnification clause," is it right? Recall measures completeness of all the indemnification clauses actually in the document. How many did the model find? Governing law and termination show high scores on both axes, which means the model has seen enough examples of those clause types to recognize them reliably. Force majeure showing lower scores is a common pattern. It's rarer in training data and uses more varied language. If you see a clause type underperforming, the fix is targeted. Add more annotated examples of that specific clause type to your training set, not a full retraining run. The risk scoring output has two components, and reading them together tells you more than either one alone. The clause level scores on the left rank individual provisions by risk. Unilateral termination at 7.5 is the highest risk clause here, followed by non-compete at 6.8 and auto-renewal at 5.5. These scores give reviewers a prioritized reading list. Start with the 7.5, not the 5.5. The contract level distribution on the right shows the aggregate risk profile across all contracts processed: 40% low risk, 35% medium, 25% high. That distribution is your operational baseline. If the high risk percentage starts climbing month over month, that's a signal worth investigating. Either counterparties are pushing harder on terms or the model's risk calibration needs adjustment. Use both views together. Clause scores for individual review prioritization, distribution for portfolio level risk monitoring.